let's get started. Scott, I work here at Steele. Going to be talking about using Rust in the browser, which is what everybody wants to do. Hopefully that means something to everybody here. If not, you will get some context for that over the course of however long this slogs on for. Has anybody here not played with Rust? No. Has anybody tried using Rust in the browser yet? Okay, great. So first off, I am not an expert in WebAssembly or compiling Rust to WebAssembly. The only reason I can kind of talk about this, and I won't be able to for much longer because it's moving really, really fast. It's just I was able to get Rust compiled to WebAssembly just before all of the really amazing tools that make it really, really easy came out. So I did have a little bit of experience with downloading stuff, trying to get it to run, and then 2 hours later having it fail, and then doing that for a while, and then finally getting something working. And then also a medium-sized Rust project that we wrote here at Steele. Casey designed, and the both of us wrote. I did get that working in the browser, and it's something we probably, that particular target for that project hasn't been deployed yet, but will probably be deployed internally facing in the sometime nearish future. So that's an example of using Rust, WebAssembly in production. So that's kind of cool. So that almost makes me feel like I should mention something about it. Yeah, so again, it's all moving really fast. And even the last thing that I mentioned in the slides was only announced yesterday, which is depressing and made me wonder wait, why am I even giving this talk? This is so much easier. There's no reason to explain anything now. Get off my lawn. So why would we want to do this? Speed, right? Everybody knows Rust is super fast and JavaScript's totally slow. Sad. Nobody wants to run JavaScript. But no, yeah. So the definite, one of the most definite early advantages is in parsing. So obviously, for people who are working in the browser, you really care about having your page be interactive, as soon as possible. Any delay in getting to first draw of your screen or first display and user being able to interact with your application is really hurts you in the eyes of the user. And WebAssembly has a big advantage there in that it's a binary format that only requires minimal validation by the browser. So it doesn't need to be parsed to the end and then reparsed in order to determine if everything's okay. It can actually, and I'm not sure if any browsers have implemented this yet, but it is you can parse and ingest it streaming, or at least it's designed for that to be possible. And it's also just a more compact format. The other thing is just that it's a model that's a lot closer to what is easily optimizable in a machine. So it itself doesn't have very many higher level niceties that can often be tricky to optimize. Yeah. I would recommend reading Lynn Clark's abridged cartoon introduction to WebAssembly. She discusses some more of like why some of the things that it's fast at now, and some of the things like where they expect to see improvement in the future. And in general, according to like the numbers that she had looked at, you average between like a 10% to what was it 100. It was a large improvement that you can see on average. There might be some specialized areas where the JavaScript VM is just really, really good at jitting stuff, and you'll get comparable or maybe even ever so slightly worse performance in WebAssembly, but generally you're going to see faster performance, which is nice. And by the way, if anybody didn't get the link earlier, if you want to download the talk so you can be like clicking links instead of trying to stenographize them down, that's the link. Great link. So the other reason, libraries. Libraries are great. So I think everybody here, again, I wasn't sure, there might have been some JavaScript people who were like not really familiar with shared libraries, but if you can compile something that has a C API, you can use it a bunch of different places. You get there's a little bit more boilerplate you have to do than like something like Java, which talks about being write once, run everywhere. But in general, like there's a really great ecosystem that a lot of these different language environments get to participate in that traditionally the web browser doesn't get to participate in directly. So instead of having to rely on server calls to employ a library or some of the older compilation to JavaScript that wasn't as performant or was just very large and so had a much larger initial delay, you can now participate in the library ecosystem, which is for front-end development, which is really nice. So the other reason to do this is because I'd rather write Rust than I'll write a little bit of JavaScript, but I don't want to write a lot of JavaScript. So in case anybody coming to the Rust meetup needs to be sold on Rust, so the main things I was going to sum that up with for why like I would want to be using Rust rather than a dynamic language are just that it has efficient. I'm reading the bullet here, so hopefully that's clear. Everyone, check my work as I'm reading the bullet, make sure I don't miss any words. Yeah, efficient expressive compile time checks. So there are a lot of things that you can encode into the data structures of your program that will be checked for you by the compiler and basically act as large like program-wide unit tests for a lot of your program behavior that you can directly use when writing your program to express your intent to other developers without a associated runtime cost. It's fast enough that you can really follow the cliche of premature optimization is the root of all evil. You can just focus on implementing first. It's fast enough that you'll have decent performance, but it has enough structure that when you need to, if you do find a hot path that you need to optimize, you can come back to it later and have like a strong enough structure and comprehensive enough checks that you'll much more likely be able to modify and optimize that code without breaking up stuff, which is great. The other reason is just that, and this relates to all of this, is that in a lot of higher level dynamic languages, you often have to kind of trick the computer or give up a lot of your benefits in order to get efficient runtime. with languages like Rust, like C++, you generally can remain idiomatic, and you don't have to like try to employ any like special tips and tricks in order to get like the best performance that the language supports. So what does it look like? It's a little, that's not really big enough, but yeah, so it's a binary format. It's directly one-to-one translatable to this WAST, however that's pronounced, format. So you can look at that. It's super beautiful. We'll zoom in on the WAST format. So yeah, this is really great. Everybody's excited to write WebAssembly. You just need like, the next version of Electron in order for your editor to like do all of this for you. It's really, everybody's excited. Now that's, and it's a really rich set of data types. It has all 4 numbers that it knows of. Let's see, nope, no more data types, that's it. It has those numbers, that's really great. So that's why, yeah, so that's why, that's kind of like why you want to be compiling to WebAssembly rather than writing it directly. So what do we want our tool to do for us? So at a basic level, right, we just want 1 or more Rust files to be turned into a WebAssembly module. Then we would then be writing JavaScript and HTML and deploying that WebAssembly module, the JavaScript and HTML, to our user. Ideally, however, it would be nice if we didn't have to write all of that JavaScript. That really friendly WebAssembly I showed you, like that's a lot of what it will feel like writing the bindings to this. Like you're gonna be operating directly on pointers. There's a lot of boilerplate you're going to be doing in order to extract things out of the WebAssembly memory area into things that you can then use in JavaScript as actual like full up objects. So that's what we really like it to do for us. So the first tool we'll be looking primarily at Emscripten and wasm-bindgen. I'll mention a couple others, but these were the primary two that I played around with. However, it doesn't really mean that any of my knowledge is up to date. Like when I revisited this after like spending, I don't know, I feel like at least 16 to like 20 hours working with like wasm-bindgen over like the winter, and then like revisiting it now, it's like it's all totally different. So it's evolving very quickly. That's a huge disclaimer. This is mostly just my perspective of trying to get a medium-sized library working. So Emscripten project written, started by employees at Mozilla. Among other things, yeah, so if you want a basic example, working Emscripten example, I have that there. So what does it do? All right, so if you compile Rust to the, I mixed the order up. I think it's Emscripten unknown wasm. It's not, yes, I think that's it. So if you compile that, there still can be lots of chunks of logic in your code that think that they can make normal operating system calls. So they might think like, sure, I can like check to see if a file exists. They don't realize the cruel prank that's been pulled on them, that they're running inside a browser where they don't have access to these kinds of things. So among other things, one of the nice things that Emscripten does is it wraps that your WebAssembly module in a nice bubble to let it think that it can make all these kinds of calls. So for instance, for the file exists call, Emscripten has implemented libc functions that just return like nothing. Just be like, yeah, that doesn't exist. That resource isn't there. But you're totally okay to ask for it. Like, that's cool. Those things probably exist somewhere. It's just not the one you're looking for. Then it does also provide some help in hooking up to WebAssembly. It's definitely a lot better than writing all that at your own, but I would equate it more to a fuse box than like a light switch. You are doing a lot of wiring. There'll be quite a bit of boilerplate. The other piece to notice here is this JS here, very fat. Some of the downloads that come with Emscripten, like all of these shims that it provides you, which are really helpful, also jump up your download size. So for me, it was helpful. It was fine because the library I was pulling in was already like a decent sized library. It wasn't just a small this is a tiny data structure library or a couple algorithms that I've optimized that I want to use in my hot path. It was more of an application that I would be writing a GUI around. So what does the Rust code look like? There's some quirks. Working with Emscripten, you need a main file, but it's intentionally left blank, or a main function rather. I'm sure I could find a Stack Overflow answer for why that is. I prefer to mock it though. That's more fun, and pretend that it's just silly. But yes, you need that there, even though you don't use it. You write your typical kind of FFI style. I generally prefer to write a safe function that encapsulates behavior, and then my public function that I expose and that's unsafe does the minimum amount of work, but it does all the unsafe parts, and then it calls the safe version of the code that Rust is checking for me. And likewise, here's another function that I expose in that project. So I have a regex comparison and a validate regex. What that looks like roughly, and I elided some things, what that looks like roughly in your consuming library is something like this. Emscripten is looking for this definition. It grabs that. It initializes it in an array buffer, and then it yields control over to you. But it provides some of these helper functions here. So for instance, that example we saw before, we need to tell Emscripten what the type is. We're having to repeat ourselves a lot here. We already had these types, in Rust. We already knew what these types are. So we are repeating ourselves. But you'll notice this is a string argument, a string output. And that's not directly supported, on its own by WebAssembly. Emscripten is providing us with the C string interface, which is nice. So it's there's still quite a bit of boilerplate, but it's also providing some facilities for us so that we're not having to do everything ourselves. So that's nice. Another nice, not nice thing, we have to tell it what our exported functions are, and I never I should have probably written something that extracts the names of the functions and generates this automatically. But I was I've got 4 functions. Vim macros are fast enough for these small projects, so whatever, I'll do that. Something that actually let me make progress on this, Emscripten is what I tried using several times last year, starting in I feel near the beginning of the year. I would try downloading and installing it. I would follow the tutorials. It would tell me I needed I don't know, the Delphi version of Xcode or something, and I would download that at 3 gigabytes after agreeing to their developer terms of service, and then I would download Emscripten and it would compile for an hour and a half, and then it would fail, and it would tell me to I don't know, be more quantum. And So that would, yeah. So I tried it multiple times last year. Every time I'd be like, oh, Rust in the browser, that sounds great. I would be like, oh, I'll go get Emscripten, and then it would not work. What I finally like was like, oh, I should just find somebody else who's like got it packaged in Linux. Because even my initial attempts to get it running just directly in Linux, there's still a ton of dependencies, and like the feedback loop, like even if it would be possible, it was still took a while for it to like tell me that it was missing something. It's like, oh, thanks. You could have told me that like a long time ago. Yeah, so this was a really helpful like starter Docker image. And so the Docker file in that repo just starts with that and then installs the necessary stuff to build Rust. So here I have an iframe running, and then I have a static file. And so the example repository is just a couple different, I think the main two that work are Emscripten and wasm-bindgen, but they're just exposing the Rust regular expression library to the browser. Yeah, so that was cool. And that's useful to us here because like the library that we're going to be using, before I got that running in the browser, like I was like, oh, we're going to be making people use this, regular expression library, which is pretty sane defaults. Like it's not like Lua, which has a really weird like pattern syntax, but at the same time, like there weren't any there weren't any easy ways for people to experiment with this other than going to like a Rust playground. And we want to send our support people to the Rust playground and be like, wait, what? Like borrow? I don't understand. So the idea was like, okay, well, we can provide you like in browser the ability to like play around with the exact regular expression engine that we will be using to like evaluate the configurations that you put together. So that was Emscripten. Wasm-bindgen. I think it came out. I'm trying to remember it. I think I first saw it's by Alex Creighton, and I think pretty much everybody knows who that is. He's like one of the. He's like a founding father of Rust. He's like done a lot of really cool work. Yeah. So. And he didn't announce it for a while, which is probably part of why it was so hard to work with, because he hadn't publicly announced it yet. And so he probably didn't intend for too many people to be like using it for work. Yeah, so if you go to the same repo and you go to the wasm-bindgen branch, there is an example there that should be, I think, working if you follow the README. So, all right, so wasm-bindgen does it. All right, so it does this initial thing that we wanted our tool to do, and the thing that the Emscripten does. It compiles, it uses the unknown WebAssembly target. And so it generates a WebAssembly file, which is great. Then another thing it does is it generates the JavaScript bindings to the WebAssembly file for us. So that then it's supposed to be a browser, but the more I look at it, the more it looks like a copy machine. Can use those bindings directly rather than having to do a lot of the boilerplate that we were doing when we were using Emscripten. Another really nice thing that it does, it also generates the TypeScript type annotations. So you can instead of just relying on documenting what your interface is, you can actually have the type annotations that, to the extent that people obey, don't use any of the workarounds in TypeScript that let them break out of the type safety. You can extend the type safety that your Rust program is giving you deeper into your consuming application to avoid type errors, which is kind of really awesome. So this is what this is some of what our Rust code looks like when we're using wasm-bindgen. So we're using nightly so that we can use this procedural macro. But we define a struct called a compiled regular expression. And then like we write a lot of methods for working with that struct, which I mean, if you've looked at Rust, like this is all pretty basic Rust. Like it's a little bit more verbose than it needs to be because I'm trying to like, you know, like kind of contained interface to the struct rather than rely on like your knowledge of how it would work. But like the main thing is just I have a struct and I have this annotation that will analyze the contents of that and generate some nice stuff for me. For instance, here are my TypeScript output. So it's found is match, takes in a string, returns a Boolean, is valid, returns a Boolean, the error message method returns a string. So all of this can be checked by if you're using TypeScript to generate your JavaScript, which is kind of really great. This is, I kind of went overboard. I'm not a front-end dev, and I was like, I'll optimize this CSS lookup. And it probably didn't optimize it. It made the code a lot more complicated. So I elided a lot of that for this example. But this is roughly what your code looks like. Like, I don't know. I think this is beautiful. It's so much prettier than the other stuff. All the other shenanigans we had to do with the other thing. Like, I'm just like calling these methods to create this new thing. I'm asking if it's valid. I'm asking if it's a match. If it's not valid, I'm returning an error message. Like I'm not getting the exhaustiveness checking that I get with Rust, you know, directly. I have to manually know to ask, is it valid? But like, I don't know. I really like this. I really liked writing this after working in Emscripten. The one gotcha you'll need to like look for is, since we are allocating something on the Rust side, and there are no ways to hook into the JavaScript garbage collector, like there are in a lot of languages that rely on FFI to use, you know, a lot of libraries that can be implemented faster. They'll give you hooks that you can use to say, okay, when this thing goes out of scope, you know, call back to free it up. We don't have that here, so we do have to make sure we remember to call the free function, or else we will leak memory inside of our the buffer that's allocated for our WebAssembly module. So if you give it a fixed memory buffer, it's not the end of the world. You'll just eventually it'll crash because it can't allocate new memory, but it's contained, and you just like your app will break, but the site will be otherwise usable. You can let it be a non-fixed buffer, and that one tab would have a memory leak, and then but when you kill that off, then you'd be fine. So yeah, so here I have it running, and it works just the same way. Yeah, so yeah, so another really so I haven't had to myself write much like foreign function interface before like this past year. So like my original like experience with that was to write like C structs and rely on the facilities of the host language to like whatever APIs it has for working with C structs and C ABI, like rely on those facilities, which often meant like my interface for like Lua was very different than an interface for a different language that didn't have the same kind of facilities for working with C struct. Like one would support arrays and another wouldn't. And so like you ended up, my like interfaces that like I wrote or maintained ended up being like very dependent on the language that the bindings were being made to. So it was nice to like see how pretty the wasm-bindgen like model was of having it goes with the model of having an opaque pointer exposing a lot of different functions and methods for operating on the object that's stored at the pointer. So I don't try to map any of the like structure of the thing that's being allocated and manipulated on the Rust side. I don't try to map that back into my language where I have my bindings. Instead, I have functions that that it exposes that give me back like the more simpler data structures that I'm able to use. So in like this case, with the help that it gives us, like strings, bools, numbers. So that was a really that was just useful for me to go through that exercise of like working with Emscripten first, where I'm just like making these like custom functions, and then see where like, oh, wasm-bindgen is just like, it's hiding all of this pointer manipulation from me. That's really nice. And in fact, the interface that I wrote, it might not be as efficient. So, like, I'm sure there are places where like maybe you can get a huge benefit from using the very specialized facilities your host language has for manipulating, C data structures. But for basic interfaces, it's really convenient. It was pretty simple after this to use the exact same interface that I had created for WebAssembly to create like Python bindings to this library. So it was cool. So some other tools, Webpack 4 or later, and they're starting to like, certain bits are starting to kind of merge a little bit with like some of the other tools, like wasm-bindgen now has some dependence on Webpack that it didn't have when I was first using it. Just part of why, if you are following along, you got a dead screen here, because before, like in the amount of time that I was preparing for this, I was like annoyed, and I was like, I have it working if I call npm run server, but I don't necessarily know the best way to tell Webpack to create static files for me. So if you want this one to be working, you have to actually be running npm. So sorry. Yeah, so they're like blending together. It sounds like kind of the default way of working with things is going to be like Webpack with wasm-bindgen once it can go off nightly. Especially for people who already have a large like client-side application that might be using Webpack or Parcel. I would think that like that would be a really helpful tool to use. Standard Web, I tinker with a little bit, not a lot. It has facilities for including JavaScript and Rust, which is nice. I didn't get as much to looking at the facilities it has for like improving your ability to safely access data structures and pass them across the FFI boundary, in the way that WebAssembly or wasm-bindgen had a lot of support for it, and Emscripten had decent support for it. I would imagine it has some of that, but I don't know, so that's why I didn't look into it as much. If I had another project that I needed to move over, like compile to WebAssembly from like that hadn't previously had that done to it, I would probably play more with it to see if it was promising. Wargo was like really popular. Everybody was like, Wargo, like here's the keys to Reddit. You win. I had the exact same issues that I had trying to install Emscripten all last year, because it was just like, okay, we know where. I mean, based on my couple times trying to use it, it felt like it was like, we know where to get Emscripten. It's on the internet. And it would like download it and try to run it, and it wouldn't work. And it would take a while for it to tell me it didn't work. And I mean, I guess so. Maybe if you did the same thing and just ran it on Linux instead of Mac, I guess I would maybe that would be better. It hasn't been modified. At least the master hasn't been modified for like 6 months now. So everybody was like, this is going to be the thing everybody uses. It doesn't look like it's being developed at all. So yeah. wasm-bindgen was really great, and it's like the fact that Alex Creighton is the one like, you know, like who kind of owns it, is the one driving it forward. Like it sounds like it's the future. I'm excited for it to be the future, but it didn't, like I ended up using Emscripten for the project, and it was more verbose. It was not as pleasant to work with. Like it wasn't horrible. It was, you know, it was just more, I had to do more work to get it working. But it played nicely with my dependencies. Like, so the fact that it let my code think that all of those things existed was really helpful, because for a reason that we don't actually need, but I didn't have time to get rid of the dependency, we have a dependency on the random crate, even though I looked, and we don't use the feature of the dependency that was depending on the random crate. We don't use any of the features that it uses that rely on the random crate. But so we have that, and then it panics, or it gets really upset when it compiles, because it's like, I rely on an operating system. Like I need you to be implementing these things, and unknown and wasm as a target like doesn't have those things implemented. Emscripten has them implemented. It's just like nothing's here. Go about your day. But like, at least as of the last, like I think I checked like last week or read about it last week, that I think it's still like the random crate in particular is a known issue where they're like, oh, we should probably fix this. Then the other thing was, and again, some of this is probably because I was playing with it before it was actually like announced. Was like there was a lot of dependency hell where it would be like, it works yesterday. Today, like maybe if I change a third of the characters in the SHA, it might work. So like it's really beautiful and amazing, but it relies on nightly, and so I would say definitely play with it. If it's for personal projects, definitely use it. But if it's something you need to collaborate on, or it's for like work, I would say go use Emscripten. Use Docker if you think there's ever a possibility that somebody who doesn't have Linux might need to help you with it. So something that was announced yesterday, I was like, that's really cool. Why am I giving this talk? Why aren't people just going to this thing? It's WebAssembly Studio, which is where I got some of the cool illustrations. So that's kind of cool. We can click Empty Rust Project, click Create, see, oh, what does it do? Oh, it adds 1 to 41. That's cool. Oh, look, it has x plus 1. Let's add 1. Oh, huh. So we click Build. Then we wait a little bit, and we click Run. Oh, look, it just called Rust in my browser. Like, this is so easy. Yeah, so like it's still, you still have to do all the FFI nonsense, but I think they said they only started working on this in like late December. So I would like, and especially for learning, like it's kind of really awesome. So I don't know. There's a lot of really cool tools. It's hard to keep up and say anything relevant because of how quickly things are changing. But I don't know. I think it's pretty exciting. I think that's it. I was going to show the demo of our project in, yeah. So I can also just quickly show the medium-ish sized project. But first, does anybody have any questions? Yeah.
Is wasm-bindgen still a thing?
Yes.
I know that was out for a little bit.
So when I used wasm-bindgen in like December, like that was one of the steps that he recommended. And then there's some other tools that are related. Let's see. I'm not sure if I still use it here. Yeah, so I still use it here in the make file for wasm-bindgen in the example. Oh, that is showing my screen. Great. And then like this, the Chrome stuff was something I had to add, like that I didn't have to do before. But I think I just commented out their example because I was like, why isn't Chrome working anymore? Because it worked in, I'm pretty sure like wasm-bindgen worked great on Chrome in December, but now with how it's packaging it, Chrome has like an issue that their Chrome needs to work on with like limiting the size of certain kinds of files. So it has to like package it to get around that. But yeah, so this wasm to ES6JS, I think is kind of like of the same ilk of like lots of little command line interface helpers. When I used wasm-gc on the stuff that I was doing, it's possible I just like maybe the code I was writing like had wasn't able to do dead code elimination enough because of all the things I was pulling in that were used in rare instances, or it was just it didn't have a huge effect on the size. It would be like 10% at most, maybe more like 5%.
And that didn't do anything with the brand issues we're having.
Yeah, the issue with Rand was like, and it has to do with, it's like a Rust issue where like if, I don't remember exactly what it was, but like you want to be careful what you declare as your default feature in order to like be able, like, I saw that it was an issue. I didn't like, not being a library author myself where I needed to worry about it. I was like, oh, if I ever am in a position where I think this might affect somebody, I'll need to make sure I look up the correct way to do this. But it was just like the way the UUID crate specified rand as an optional dependency didn't allow you to specify a feature that would let you opt out of it, even though it was it's only one of the UUIDs that requires the rand crate. And it is feature bound. You can be like, hey, I don't need that feature, but it doesn't propagate through to the rand dependency. So I tried and we have everything vendored there. So I was like, oh, well, we have everything vendored. I can just modify the crate. And I tried a million things to try to kill it off. Like, yeah, it's something with how you specify like default or whatever gives the downstream consumer more flexibility about getting rid of features they don't actually need.